Hi, I'm Jonathan Oxer, and you are watching Sonoff Secrets. Actually, hang on, no. This is... Superhouse, I think. Could be the Sonoff show now. My recent episode about the Sonoff was really popular, and if you haven't seen that one, you should probably go and check it out before watching this episode. But just as a brief introduction, the Sonoff is a little Arduino compatible board with an ESP8266 microcontroller inside, which is Wi-Fi enabled. It allows you to run off mains power and control an output, so you can use it to turn devices on and off. Mains loads like lights, that sort of thing. It's now spawned a whole lot of different variations. There's a whole series of them. This is the original Sonoff. There is now also the Sonoff Dual, which has two outputs, so you can turn two different devices on and off. There is the TH10. TH stands for temperature and humidity. It's got a socket on the side so you can plug in a temperature and humidity sensor, and then you can have logic in the software that lets you do things like turn things on or off if the temperature goes outside a certain range or whatever. And there is the TH16, which is the same thing but 16 amp rated instead of 10 amp rated. There's also the slamper that I showed in the last episode, which is in the form of a light fitting. So you unscrew your light globe, put the slamper in, put your light globe back in, and you got control over your lights via your phone. There is now also a light switch replacement. This is a touch screen, a touch panel. So basically you touch this, turn your lights on and off. You just remove your old light switch, screw this in its place, and you now have control over the switch either by touching the front plate or from your smartphone. And of course, if you replace the firmware in these, you can connect them up to MQTT. You can do whatever you like, link it to your home automation system. This is the European format, and this is the American format light switch. So what I'm going to do today is talk to you about a few of the slightly unusual things that you can do. If you've got some Sonoffs and you want to do extra stuff with it that is more than the original maker intended, these things are very easy to hack. So I'm going to show you some little tips and tricks. One of the limitations of the Sonoff, just as it comes out of the box, is that it doesn't have much flash memory to store your program. It might sound like a lot because these have 8 megabit memory chips on them, but it's really not that much. Now, one of the things you have to keep in mind is that's 8 megabits, not 8 megabytes. So you divide by 8, and that gives you 1 megabyte of memory. It's suddenly sounding a lot smaller. But it gets worse. If you want to do over-the-air updates, the way that process works is the new program needs to be uploaded and stored in the flash with the original program still in there. That means that your program can only ever use half the size of the flash. Now you're down to 512 kilobytes. That's starting to get tight. But it gets even worse than that. If you use a SPIFS, which is an SPI flash file system, to store non-volatile data, that takes away part of the memory as well. So it's fairly normal to configure, say, a 1 megabyte memory with 64K SPIFs. So 64K of your memory is taken away. So by the time you divide by 8 to get megabytes, then you divide by 2 to get the amount of space you got available, then subtract the space required for the SPIFs, you're not really left with a whole lot. So one of the things you can do is replace the flash memory chip on the board to give yourself a storage upgrade. That may not seem like an obvious thing to do if you're used to like a regular Arduino, because the thing is that with a standard Arduino, the main microcontroller contains everything. It's the processor, but it also has all of the flash inside. With the ESP8266, it's a little bit different. On here we've got the ESP8266 sitting on the bottom of the Sonoff, but the ESP8266 itself doesn't contain the flash that stores the program. That's in a separate memory chip, which on the Sonoff is sitting on the other side of the board. So this little chip here is actually where your program is stored, unlike in the Arduino where it's stored directly in the MCU. So what we can do is replace this memory chip, and all of a sudden we've given ourselves a memory upgrade. Luckily the chips are really cheap and easy to get. I got these for, I think it was about 30 cents each, so I just ordered a bunch of them. These are 32 megabit memory chips. So that gives you a whole lot more storage than the 4 megabit chip that comes on the original Sonoff. So I'm going to rip this one off, put on a new one, and have ourselves an upgraded Sonoff. You might think that the idea of replacing a tiny surface mount chip like this is ridiculous, and if you haven't done much electronics assembly before, it can be quite daunting. Now if you look at my workbench, you'll see I've got all the gear you could possibly need for doing this sort of thing. I've got a whole collection of different soldering irons. There's a microscope, obviously. I've got a PCB preheater for doing reflow work. There's a hot air system up here. I've got a air-driven solder paste dispenser. So like everything that you would need. But I don't even use that for doing this. So don't think that you need lots of expensive equipment to replace a chip like this. You can do it just with a budget soldering iron and a pair of tweezers. And I'm going to use a big soldering iron. I've gone for a large tip. This is not a super fine point, as you can see, compared to the size of the chip itself. I'm going to show you can do it even with this sort of iron. So very first thing I'm going to do is add some more solder onto the pins for this memory chip. So the idea is we want to get it to sort of all ball up and have solder across the side there. What that allows us to do is heat up all of the pins at the same time. So I can get my screwdriver in here, heat it up, lever up the chip, and there we go. See, one side of it is off and it's that easy. I'll turn it around here. It's a little bit difficult to see just because we've got these other things in the way, but I'm going to do the same sort of thing. Ball up a bit of solder and get my screwdriver in on the other side, heat it up, slide this off, and the chip is away. So we now have the old memory chip removed just in a couple of seconds with a big clunky old soldering iron. No need for a super fine point. Now that the old chip has been removed, we just need to clean up the solder pads a bit. These ones are already pretty good, but if you take a clean soldering iron tip and then just drag it across the pads, that will leave a little bit of solder behind. You'll see that there is a slight amount of solder on each pad, but not a large clump. That'll be enough for us to put the new chip on. Have a look on the circuit board. You'll see that there is a little dot right here. That is to signify that this is the location for pin 1 of the chip. And then if you look on the replacement memory chip, you can see that there is a dot right here on this corner. That's also pin 1. That means we have to orient the chip so that the dot on the chip matches the dot on the PCB. So we'll just put it on like that, and then make sure that you get it aligned so that the pins on the chip fit directly over the pads on the circuit board. And now, while using just a little bit of pressure from these tweezers to hold it in place, I can just touch each pin with the soldering iron, and I'm still using this big clunky old soldering iron, and that's enough to reflow the solder, and this chip is now attached in place. All these pads are in, there are no jumpers, and there are good connections. Just got to turn it around, do the other side, and the chip is done. There we go, it's as quick and easy as that. Now I can do one of these probably in about 30 seconds using nothing but big old soldering iron and a pair of tweezers. That's really all you need. Sometimes though, things don't really go according to plan. On this particular Sonoff, I applied too much heat when I was taking off the chip, and I lifted one of the pads off the PCB. So what I did was fitted the chip and soldered the rest of the pads in place. But with this one, what I did was trace through on the circuit board where that pad went. Turns out that it connects onto the ESP8266 just down here. So I got a little bit of wire up wire, just very fine wire, soldered it onto the pad on the ESP, ran it through a hole on the board, which is where there's a part that isn't placed, and patched it in here. So even if you mess up, you can resurrect it. That can be pretty difficult though. Because Sonoffs are mains rated devices, safety is a really important factor. I've seen some tutorials online that show really bad practices. For example, it's pretty common for introductory tutorials to show you to just cut the lead of an appliance or something like that and splice this on off in the middle. That is really handy and it's a good way of showing you how it works, but it's not enough. What you can do is take, say, a little extension lead like this one, or a power board or an IAC lead, put a Sonoff in series with it, and now you've got internet control of your device. But there are a couple of things really horribly wrong with this picture. Firstly, see this? That's the earth connection. I've seen videos on YouTube where they just cut the cable exactly like this, splice this on off in the middle, and leave the earth connection floating like this air gap is going to magically conduct current or something. That is a horrible idea. So you probably will have to use a little screw terminal joiner or something, but make sure that the earth is connected. Secondly, leaving it just like this is really not enough. So imagine that you've got one of these in series with the power to your Christmas tree, which is a great use for it. And you know, friends come over, it's a couple of days before Christmas, kids are running around all over the place, they're excited, they're running around the tree, and one of them trips on the cable, or even just grabs it and pulls. So splicing a Sonoff into a power cable is actually a really great idea, but you have to do it the right way. I'm going to show you how. Now the important thing to realize is that this Sonoff box itself provides a fair bit of protection, but it's not really designed to be the final box. This is not really intended to be exposed to end users. Normally this is something that you would build into something else. You might fit it inside your ceiling or somewhere that you can wire it in permanently, but you're not going to get little fingers getting in here. So what you need to do is find some kind of a box. Could be a project box, something like this, plastic container that you would use for a typical electronics project. You just need something that this goes inside that provides a couple of things. Firstly, you need to be able to provide extra strain relief to prevent the leads being pulled out, and also access, so little fingers and screwdrivers, and a kid with a knife can't get in here and make contact with things, and also to protect against liquid spills, and that'll really help keep your project safe. Now you need to think about the final situation where your Sonoff is going to be mounted. If it's going to be anywhere that's exposed to the weather, you really need to be very careful about how you package this up. Now the best way to do that is with an IP rated case. So this is a plastic project box which you can put things inside. It comes with this little bit of rubber that goes around here. It's like an O-ring, so when it seals, it pushes the O-ring down and seals around the edge here. It's there, very thick and strong. Now IP rating, you may have seen things saying this is IP rated IP45 or IP56. What IP rating actually stands for is ingress protection. And there are two different types of ingress protection. The first is mechanical. So that is protecting against things like someone shoving a screwdriver into it, or dust penetrating in and causing problems with your device. So when you look at the IP rating, the first digit is the level of mechanical protection. The second digit is the level of liquid protection. You might have something that is just protected against a bit of water being sprayed on it, or you might have something that's protected against being totally immersed in water. And if you look at the original Sonoff package, this has fairly good physical ingress protection, but it doesn't have very good liquid ingress protection, because even with these covers on, there are big holes in it. Liquid can go straight into it. If someone spilt something on this, they could electrocute themselves. So when you look at something which is IP rated, it might say something like IP56. That means it will have a 5 rating on mechanical ingress protection and a 6 rating on liquid ingress protection. Now of course you also need to get cables in and out of the box, and that's where you use these little things. This is called a cable gland. What you do is mount this through the side of the box. The cable goes through it, but there is a seal in here. There's actually a little rubber O-ring. Now I may not be able to get this out easily. Oh, there it is. So what happens is that the cable goes through the O-ring, and the O-ring makes a nice firm seal around the edge of your cable. And I would normally push this through a bit further, but the O-ring then goes in here, and of course I would have this on the cable first. That screws on, squeezes these little fingers, and the O-ring then seals around the cable, and you effectively get pretty much a waterproof seal. You can even get these with glue and various other things in them to make them totally waterproof. So you could make something which is submersible. If I fitted this little O-ring gasket and used these proper seals on here, I could put this Sonoff inside, and I could basically have this turned on, connected to mains, stick this in a bucket of water, and it should be just fine. There we go. Now the cable glands are in and it's ready to insert the cables. There we go. Cable glands are in place. Cables are all tightened up. Because it's got these rubber grommets around it, these are pretty much watertight now. Like, I would probably put silicone around this if this was actually going underwater, but it's certainly fine to be out in the rain. And it also provides mechanical protection, so I could probably just about hang off this. It's really strong. So now we have a device that should seal up pretty well. I've got the input side wired up here, active neutral on the output side here, and you can see that I've connected across the earth as well. There, now that's a Sonoff you can deploy anywhere. Of course, you don't always need to use an ingress protection or IP rated plastic case and make it all waterproof and sealed. And yes, I'm very well aware that this plastic box probably costs more than the Sonoff that you're going to put inside it. In fact, a couple of these cable glands probably cost more than the Sonoff you're going to put inside it. So you've effectively tripled the cost of your project by doing this. But it's the difference between doing it the right way, the safe way, and doing it in a dodgy, half-assed way that could well get someone killed. So you've got to think about how you're going to use this in real life and possible ways that it could go wrong. Make sure you do it the right way. And most of the time, a cheap plastic project box will do just fine. Just make sure that no one's going to kill themselves because of your project. If you've mounted a Sonoff inside a box, you can control it with your phone or via Wi-Fi obviously, but how do you control it manually? I've had lots of people say, how do you hook up a button to this? For example, if you wanted to replace a light switch in your house, what you could do is take the existing light switch off the wall, wire this in place of the power that is switched by the light switch, and then you need to connect a switch or something on the wall to actually control this manually. That way you can just walk up to the light switch, use it as usual, and you can also control it from your home automation system. That is actually pretty easy to do. Now on the top of this there is a button which is used to put it into programming mode. It's connected to GPIO 0, and in a lot of the firmware that's available, including Thea Arenz's firmware, if you press that button it will toggle the state of the output. So without any additional software changes, if we can trigger this button somehow, then we've got manual control over this. If you're willing to do a little bit of hacking, that's pretty easy to do. Let's have a look. So we want a way to be able to trigger this button from some external system. And what I'm going to do is mount a Sonoff inside this plastic box, and I'm going to use a power board so that this is basically going to be in series with the lead of the power board. So I've got a controllable power board, but I want to be able to just press a button as well and turn the power board on and off. So here's what I do. With this one, I've drilled a hole through the top of the case. It's just between these two, like near the LED and the button, a little bit above it. And if you look on the inside, this is where the push button is. It's connected to GPIO 0. Now, the two bottom connections on this button are the ones that you need to close if you want to trigger it. So what I can do is just use a little bit of wire, solder it onto those two connections on this switch, have it come up through the case, and then wire that to this button, put it all inside the case, and away we go. There, and now this wire is soldered across these pads, so if this is shorted, it's now effectively doing the same thing as pushing the button. So what I've used here is a momentary action button. It doesn't latch. It's only on for as long as it's pressed. So that will emulate the action of pressing this button here. I haven't used cable glands on this one because I'm just taking a bit of a cheaper approach, and this one doesn't need to really endure nasty conditions. So I put some cable ties around the leads where they come in and then covered them with hot glue. So that's pretty strong. That'll do for this application. The switch in here has got a bit of hot glue over the back of it as well, just to put some strain relief on the cable so it doesn't break off the solder joints. Then all I have to do is put the Sonoff in there, wire it up, bridge across the earth connections just like I showed you before, and then we have ourselves a power board with a Sonoff in series with it and a button that we can use to turn it on and off, as well as controlling it via Wi-Fi. Now the input side comes into the input of the Sonoff, output goes out to the power board, and the button is wired across the back of this button. So pressing this, it's the same as pressing this. The power board I used for this demonstration has a handy power LED on here, which means we get a visual feedback of when it's turned on. So now we just have a power board with the Sonoff in series with it. And if I press the button, the relay in the Sonoff turns on, Powerbird turns on. And I just press it and turn it off. And of course I can control that from my phone or from the home automation system or whatever, because this is on Wi-Fi. There is one thing to be careful of with this approach. Because this button is across GPIO 0, if someone wanted to be malicious, they could do some things with this. For example, they could press this button in, hold it, and then power cycle your device, and then it's going to go into bootloader mode and never come back online. Or if you're using Thea Aren's firmware, there is a button sequence you can press which resets it to defaults and clears all of the settings that you might have saved in it. So I really like this approach because it means that there are no software changes required. It all just works. But you just need to be aware of that. There is a solution. There is another way you can hook this up. Inside the Sonoff is this little header that we've been using to do firmware uploads the first time to replace the default firmware. Now for that we use the first 4 connections, and this one here is ground, but what's this 5th one? This is a connection that we haven't been using so far. It's actually GPIO 14 on the ESP8266. What that gives us is an extra I/O line that we can use to sense an external switch. Even better, because the Sonoff is designed to have a sensor attached to it, something like a temperature and humidity sensor, using this pin, there is a 10K pull-up attached to it. That means that it's dead easy to attach a switch. All you have to do is attach the switch between this pin, which is pulled high by default, and ground, which is here or it's available here. So you could have firmware in here which simply detects when this pin, which is GPIO 14, is connected to ground. Then it knows the switch is closed. When it's not connected, it knows the switch is open. Super handy. Now if you're wanting to replace existing light switches that are on the wall, one of the things that can be annoying is the fact that these switches aren't buttons, so they latch. It's on or it's off. And so how do you connect the Sonoff behind this and make it work exactly like a normal light switch, but also have control from your home automation system? There's a trick. With the button that I've been demonstrating so far, it detects the button press as being an event and then it toggles the output. What you can do is have your software detect not just a button press event like a close event, but have it detect a state change. So by connecting one of these screw terminals onto ground and another screw terminal onto GPIO 14, the switch will either be open or closed. And what you can do is detect if the state changes from open to closed, you consider that one event and then you toggle the output. And if it changes from closed to open, you consider that another event and toggle the output. Now you might be a bit confused about that. You might just say, well, why not just say when it's closed then you turn the output on, when it's open you turn the output off. The reason is that you will end up in a situation where you change the state using the switch, but then your home automation system won't be able to change the output state. What you need to be able to do is say, turn the light on using the switch, then turn it off using your phone, and then next time you flick the switch, it'll turn it back on again. So each time you change the switch, it toggles the output. It's not sending it to an absolute value like it must be on or it must be off. So to demonstrate what I mean, here is a Sonoff which is connected. It's currently powered up and it has this lamp on it, and it is totally unmodified other than the firmware that it's running, and it's got that little header on it that I used to load the firmware. So what I can do now, of course, is press the button on it. Each time I press the button, it toggles the output, because that's what the firmware tells it to do. I can also control it from my phone. And now this is the tricky bit. I have this mains switch, which is not switching mains anymore. All it's got is a couple of lightweight leads on it, and I'll plug it into the headers. So it is now connected into the ground header and GPIO 14, which is the top one. So now if I flick this switch, it controls the output. But notice that if I go down, it's off. If I go up, it's on. And now I'll toggle the output using my phone instead. So it goes off. And now if I go down, it'll turn it on. So the operation of this switch has actually become inverted because the state was changed by another system. So now I've turned it off. Next switch change turns it back on again. And of course you can use the button as well. So that means that any of these inputs, either flicking the switch, pressing the button, or using the message via MQTT, will cause the output to change state. This means that you can have a direct drop-in replacement, mount this on the wall, and as far as anyone is concerned, they think it's just a normal light switch because it behaves the way a light switch normally works. But you can also control it via MQTT or whatever other firmware you happen to have running on your Sonoff. And if you want to try to minimize the amount of time you spend messing around inside the Sonoff, what you can do is go for something like the Sonoff TH10 or TH16. The reason is that these are specifically designed to have the external sensor. They've got this little socket on the side to plug it in. And it's a little 2.5mm four-way plug socket. So we can plug that in. And exposed on this is ground 3.3 volts, GPIO 14, which is the same as the one inside the normal Sonoff, and GPIO 4, I think it is. So here is the Sonoff TH10, wired up as you normally would. Power comes in, power goes out to the globe. So if this was powered up, it's not right now, I could control this the usual way via the network or by pressing the button. And it's running the same firmware as I've just been demonstrating. And over here, I have the light switch wired up to a 2.5mm TRRS or tip ring sleeve connector, similar to what you'd find on a set of headphones or something like that. And this is designed to plug straight into the side here. Now one of the difficulties I had is that on some of the Sonoffs, the socket is set a bit too far back inside the case. So what I've done on this one is I took the cover off, drilled a 10mm hole in the cover, and that leaves lots of nice clearance around the socket. That way we can plug this in, it seats in properly, it's not held back by the plastic. That's just something you may have to be aware of. So now we have the Sonoff, it's connected to the switch, and I will plug in the power. So it's now come to life, and as usual, if I press this button, it'll toggle the output. And if I flick this switch, it also toggles the output. So I turn it on, turn it off there, turn it on, turn it off there, turn it on, turn it off. So now we have a switch you can mount on the wall that will control the output, and we can control it via the network. You don't even have to solder anything to the circuit board inside here. It's external, just plug it in. So now we've seen how to connect a device into the temperature and humidity sensor version of the Sonoff using GPIO 14 exposed on this little socket here, and doing the same thing on a regular Sonoff by accessing the internal header. Now the reason that IT exposed this header is they make available a couple of different sensors. This is a DS18B20 temperature sensor. It's totally sealed, so this is submersible, at least up until the end of the lead it is. And there is also this, which is an AMS2301 temperature and humidity sensor. So with this you could do things like set a trigger point, and if the temperature or the humidity goes outside a certain range, you turn on the output. All you have to do is plug the sensor into the Sonoff, and as long as your firmware is using GPIO 14 to read from the appropriate sensor, you're all set. Easy. But of course, it's just a GPIO, so we can connect anything to it. Anything that you can communicate with using a single GPIO line, and it could be something like a one-wire bus system, it could be serial data coming in. For example, you could receive accurate time updates from a GPS module, or you could receive data from an RFID reader. So you could have an RFID reader plugged into your Sonoff, and if it receives a certain scan, it's accepted by the Sonoff and it turns on some device. So you could use it as a safety interlock on a piece of industrial equipment. You can really do anything you like because you've got that extra GPIO line. What would be cool though is if we had two GPIOs. Let's have a look how we can do that. This is the Sonoff TH without its cover on. And right down here you can see the 2.5mm four-way socket which is used to connect the sensor. Now if we turn it over, we can see here the connections on the bottom. Right here is the end of the socket, and these are the connections that go to the different parts of it. So the ring, the tip, and the shield. So just down here you can see a couple of little resistors, and you can see that there are some spots that are vacant. This 0 ohm resistor that you can see right here connects GPIO 14 to one of the pins on this connector, and this little resistor that you can see, it says 103, that means it's a 10k resistor. That is a pull-up to 3.3 volts for GPIO 14. That is how the sensor is connected. However, there are parts missing from here. That is because GPIO 4 is brought out to these pads right here, but it's not connected. The parts are missing. So the fourth connection on the socket is just left floating. We can fix that. If you simply put a 0 ohm resistor across here, or just a pad of solder, you just need to bridge that, you will link GPIO 4 through to this socket. That then gives us two GPIOs and we can connect all sorts of extra things. And then if you put a 10k resistor across these pads, that gives you the pull up to 3.3 volts. Now obviously soldering parts that small is pretty tricky, so you may not feel comfortable doing it, but if you've got a bit of a good light and some magnification, I'm going to use the microscope. It's not too hard to put a little solder bridge across those jumpers and put in a pull-up resistor if you want to. You can even use a through-hole resistor. You don't need to use a surface mount resistor. You could use a regular through-hole resistor, bend the leads around, make sure it doesn't short anything, and solder the leads onto those little pads. So as you can see, now I've bridged across these pads with a blob of solder. I couldn't be bothered getting a 0 ohm resistor out. And I put a 10k across here. So we now have GPIO 4 connected through to the extra connection on this socket, and we have a pull-up on it, so we're ready to use it with software. Now that we have GPIO 4 connected, that leaves us with the following pinout on the TRRS 2.5mm socket. So if you can get hold of a little connector, you can solder up your own jumper leads and follow the pinout that you can see here on the screen. I'm also going to put this diagram on the blog post for this particular episode, so it'll be there for your reference. So now I have this Sonoff running just off a bench power supply. I'm just supplying 3.3 volts here to run it up, and I've got my 2.5mm TRRS connector and then some ribbon cable coming out and breaking it out here on this solderless breadboard. So the connections are 3.3 volts, ground, digital pin 4 and digital pin 14. Then I just have these LEDs showing the state of the outputs of those two digital pins. The sketch I'm running on this right now is basically just blink, but instead of only outputting to one LED, it's outputting to two digital pins and it's just alternating them. So that's showing that we have control now over both those digital outputs. So even though I have digital pins 4 and 14 running now and I can control them, one of the things I've failed at is getting I2C working properly. Now if I run the Tasmotor firmware that I'm going to show you a bit later in this video, I can do an I2C scan and I can find devices that are on the bus, but I so far haven't been able to write my own code that talks to it properly and gets it all working. But at least we've got a couple of digital I/O lines, which gives us lots of possibilities. So what do you do if you want two digital I/O pins from a regular Sonoff, not the Sonoff TH? Well, we've already seen that this top connector up here is digital pin 14. So we can use that just the same as we did on the Sonoff TH. However, getting to GPIO 4 is a lot more difficult. Down here on the ESP8266, the GPIO 4 connection is this pin right down in the bottom here, and it's not connected to anything. There is nothing else on this PCB that pad goes to. So to connect to it, you need to solder a wire onto that tiny little pad of solder. Now that's obviously pretty difficult, but I already showed you earlier that it is possible to solder onto that if you've got good lighting, good eyesight, and very fine wire. To really take control of your Sonoff, you need to replace the firmware. The factory firmware that comes on it is great if you want to use the eWearLink software to control it, but it really doesn't give you any flexibility. Because you can upload your own firmware, you can put anything on it that you like. And in a previous episode, I showed you how to do exactly that. There are many different projects around for new firmware. It seems that lots of people are writing their own systems to solve their own particular problems. So there are many examples out there if you want to write your own, or start with someone else's project and then do something that suits yourself. For example, you can start with ESP-Easy, which is a general purpose control platform for the ESP8266. There's also Esperna and Esperuino, both of which run really well on the Sonoff and let you control the outputs. There's Node MCU, of course, which is a platform that runs on the ESP8266 and lets you run Lua code on top of it. There's Pete Scargill's HC 2016 firmware, which supports MQTT and is pretty fully featured. And there's also Theo Aren's software, which I've been calling Tasmoda after I saw it referred to that in the ESP8266 hints blog, basically because it doesn't really have a proper name, and that's just an easy way to refer to it. So originally for this part of the video, I was going to show you a few of these different firmwares and compare their features. And then I realized that really the only one you should care about if you're getting started with this is Tasmoda. The other firmwares are really good for different purposes, and it's definitely worth having a look at them. But if you just want something that you can flash straight onto your Sonoff and start using it and changing the configuration straight out of the box, Tasmoda is fantastic firmware. The project itself is called Sonoff MQTT OTA Arduino, which is pretty much a mouthful, and that's why I just call it Tasmoda. It's much easier. And it grew out of Theo Arenz's work to provide some firmware to run on his Sonoff, and also include over-the-air update support, hence the OTA name. And it's developed a huge number of features. Theo develops it very actively, so it's always getting new releases. On the GitHub project for this particular code, you'll see that there are some examples of different boards that it can be used on. There's a wiki which shows how to do a whole lot of different things in it. There's excellent documentation there. But if we have a look at the code itself, I'll point you to a couple of things that can be a little bit confusing at first, but it'll really help you get started if you know these things in advance. You'll see that there are many different files. It's not just one file which you might be accustomed to with an Arduino sketch. There is a sonoff.ino file, which is like the main sketch, and then there are a whole lot of other files as well that support it. So it's broken up logically into different areas. Most of the time you won't have to change anything in any of these other files, including sonoff.ino, unless you want to make radical changes. The configuration is pretty much all done in userconfig.h. Now one thing to keep in mind is that there are really two different types of change that you can make to Tasmoda to make it behave the way you want. The first is changes that you can make in here that affect the way the software itself is compiled. For example, if you select a different module, that then has effects later on in the compilation process to determine what features are turned on. Obviously that is something that can only be done at compile time, so once you have set that, it is fixed for the particular firmware that you generate or that you compile from here, and it won't change after that. So if we come further down here, we will see, for example, I'll scroll down a fair way, that it says if module is equal to Sonoff, so if we'd selected Sonoff as our board type, it defines an app name, a group topic, and a whole lot of other things I won't explain right now. But it defines things like the LED pin. So it's setting up things that are specific to the hardware. So those sorts of major changes control which features are compiled into the firmware. But you can also make changes on the fly. So once this firmware has been installed, the particular features that are compiled in are fixed, but you can then change settings such as the MQTT topic that it listens to. You can change a whole lot of things actually. So what you can do is compile once and then distribute that firmware to all of your Sonoffs and then just configure them differently to give them different names. Now the way this works is that it uses a SPIFS, which is an SPI flash file system, to store configuration information. So you can even flash new updated firmware onto your Sonoff, and it will remember all the configuration that you've done previously for the user specified configuration anyway. If you change the options in here, the compiled in options, it will change. But if you do something like upload firmware and then set an MQTT topic for it, and then upload new firmware, a new version for example, it will remember what you set previously. So just keep in mind that there are those two types of configuration that you can do with Tasmota. There is the once-off compile time settings, and then there are the settings that you can apply later once it's running on the board. So what I do is set all of mine to have Sonoff as the project name, and that also is used to determine the MQTT topic. If you just left it the same, it would mean that every Sonoff would have the same MQTT topic, and that would be no good for talking to it. So what I do is have them set to Sonoff to start with, and then after it's been uploaded, I configure it to put the settings in to give it a different name. And that way every one of my devices has a unique name. Earlier I explained how to connect an external switch or button to control a Sonoff, and the support for this is already built into Tasmota. So you can see here that it's saying if the module is a Sonoff, then define the switch pin as 14, and it says switch mode is toggle. So what this allows you to do is either use a button which is momentary, so that each time you press the button and release it, the state changes once, or you can have it set so that it's a rocker switch. So you flick the state of the switch, and like you close the switch, the output toggles, and then you open the switch and the output toggles. And that's all configurable through here. So you can even reconfigure this on the fly. So all you need to do is uncomment this use wall switch option, and you can then connect the wall switch to control it. Down here you can also see that it has I2C pins defined. There is pin 4 for SDA and pin 14 for SCL. And as we were connecting sensors to our Sonoff a little while ago, we saw that these are the two pins that are exposed on the Sonoff with the sensor inputs. So the Sonoff TH10 and the TH16. And of course this is supported directly in Tasmota. So we can connect I2C devices into that external socket, and then Tasmota can read it. So what you can do is simply uncomment the define send telemetry I2C, and then it will periodically take readings from sensors that are connected on the I2C bus. And you need to define, of course, what particular type of device you've got connected. Now there are a vast number of settings in Tasmota. It can do an incredible number of things, and I'm stunned that it can fit inside the standard flash memory size on a Sonoff and still support over-the-air updates. So I could spend an entire episode just going through Tasmota and the things that it can do. I can really only just give you a brief overview here, but it's definitely worth looking out for. If you want to try replacing the firmware on your Sonoff, check out Tasmota. And the final Sonoff secret, which is not really a secret at all, is some of the awesome websites that you can access to get more information about it, the Sonoff itself and also the ESP8266. So of course we start with the ESP8266 community forum. It's an enormous forum. It's got 25,000 members, a huge number of posts. It's not just about the Sonoff obviously, but because the Sonoff itself is so tied up with the ESP8266, then there is plenty of information in there. Another site that I personally love is Pete Scargill's tech blog. He talks about home automation, and he seems to do a whole lot of the same sort of things that I do, and he blogs about it much more effectively than I do. So he does lots of interesting things with the ESP8266 and with Sonoffs, and also lots of other devices. So that's a great place to get some ideas. I can thank Pete for the idea for the memory chip replacement on the Sonoff, and inspiration for many other projects as well. That's one of my favorite ESP8266 related sites, so check out Pete's tech blog. Another place to get information, even if you are not using his firmware, is Theo Aren's wiki page about his Sonoff MQTT OTA Arduino firmware, which runs on the Sonoff. and you may not be using that particular firmware, but the wiki pages themselves are full of interesting information. He's got information about how to do uploads of software and connection diagrams and various other things. It's definitely worth having a look. Tinkerman is also a very interesting blog, and once again, it's not just Sonoff, it's broader than that, but it covers lots of home automation related things, lots of Internet of Things devices, and he has lots of interesting ideas, so it's worth checking out the Tinkerman site. And another one that I came across just recently is the ESP8266 Hints blog. I'm not sure who actually writes this. It does have some really interesting tutorials on it. It's got some really good ideas about ways to use Sonoffs, and it's got some really good explanations of things like Theo Wren's firmware as well, so that's definitely worth a look. And finally, if you are watching these videos just on YouTube, you're probably missing out on all of the other content on SuperHouse.tv. The videos that are featured on this particular YouTube channel are accompanied by a whole lot of extra information on the SuperHouse site. So if you're just looking at this on YouTube, have a look down underneath. There will be a link to the page for this particular episode, and each of these episodes has a whole lot of additional information, links to all of the things that I talk about, and just other resources, things like code examples that might be on GitHub. There's a whole lot of stuff that you can copy and paste rather than having to type it all in yourself or read things on the video, which is not very convenient. So the video is really just the small part of it. You should check out the rest of what's on SuperHouse.tv as well. So there's been a huge amount of information presented in this video, and what I'm going to do is put lots of information on the blog post associated with this. So if you just watch this on YouTube, you'll miss out on most of it. Make sure you look in the video description, there'll be a link to the page, and then from there will be references to all sorts of things like the various software that I showed you. And I'm probably going to keep doing videos about Sonoffs because IT keep releasing new models. There have been new ones that have come out just while I was making this video. I can't keep up with it, so there is lots of stuff to cover in the future. And I would really like to hear from you. What sort of things have you done with these? What projects have you built? And do you have little tips and tricks? Make sure you stick them in the comments below on YouTube or comment on the blog post on the SuperHouse TV site. Thanks, and see you next time.